Hey guys, I've got this Ultrak 495 lap timer. I've actually got about 3 of them, and they all have the same fault, which has taken about 3 years to occur. It's a bit strange, isn't it? It's almost like planned obsolescence. They're all failed around the same time. There's actually more of these with the same fault, but if I can make these work, I might get a bunch more. Now, the fault is you push start stop and they don't go. What does mode do? Mode resets everything. Okay. Start stop doesn't work. Of course, that's your recall and lap split, what have you. So it's not going to split anything if it's not counting. And then oh, hang on. No, I read that wrong. Blue's not what the button does. Recall, and this one is lap and split and reset, which when you push it, resets. So that makes sense, but I don't think the mode button should reset things, should it? It doesn't make sense at all. So it's almost like the start stop button is just completely ignored. I mean, it could just be a faulty button. There's a thought. That wouldn't make much of a video, would it? I'm just going to get in the back. Well, let's flip it around and show you there. So that's inside. We've got a coin cell battery, speaker, just 3 tactile switches for the button. We have a blob chip and possibly an EEPROM for storing timing data. I haven't. We'll have to have a close look and see the number on it, but that's a guess anyway. What else would you have a chip like that for, and something like this? There's a little inductor there, and not much going on that side. That's probably all of it. So this is the start stop button. What if I just short it with the tweezers? You know, you'd sort of expect a beep, and it's not counting. You'd expect a beep if that was actually got to be it. Nah, nothing going on, so we'll check the switch, but it's probably not that. Don't like the way that coin cell holder is sitting. Like, I know it's working, but it looks like it's broken. Lift it up at the end there. Won't be the problem, but probably shouldn't be like that. Let's start with checking the switches, shall we? Just because I know that's not going to be a thing, but they're very basic unit, so I might as well start with the basics. I'm going to go resistance mode, just to make sure that they are dead short when they go. Now you'll notice I've taken the battery out. You don't want to do this with power attached. Try again. Okay, there we go. Bad connection. 0 ohms, so that's good. Go that one. 0. That one. 0. So it'll be pulling the signal down as it should. A high resistance in the switch could leave it at a weird floating voltage, which could upset things. But no, that should be giving a good on-off signal. Let's maybe go under the microscope and see what else is going on there. Well, that chip is a FT24C16A. Kind of sounds like an EEPROM to me. I wonder if they have a firmware in that, or if maybe it's just for time keeping, storage, memory. So there is a memory function. I wonder if the EEPROM is just dead, and because it can't write to it, it no longer functions. Maybe it does a little bit of a test when you first power it on. That's an interesting theory. I mean, there's not much else to it, really. These appear to be soldered on solidly. Yep. Nothing wrong with that. And we will make sure that the legs go to where they should. And that is going to... Oh, that's a capacitor. That's interesting. There's a wire there, so it could be fed from somewhere else, unless that actually connects to ground. No. And this goes to a hole. Got a little resistor there, and we got a couple of bits down the bottom, and yeah, really, you'd think if they were dropped, something like that would break loose. And you could drop these easy enough, they're always out in the wild. There was mention that maybe these could be reset by shorting these pads here, but I'm not so sure. Looking at it, it almost looks like they might go to the battery. Negative. No, it doesn't go to the battery. Doesn't go to there either. Okay, well, there might be some specific function. I wonder if that goes over to there. Huh. So there's a transistor, which doesn't appear to even be the base, going to that pad. Marked minus, and this pad is marked plus. Diode. There's no diode here. D1. There's no diode there. The pads are quite large. I doubt they would have been intended for a diode. But if you were to short these, so we have battery positive into this resistor, through the resistor to here. So that would send battery positive through to this transistor. But what's this going to even do if it's not turned on? We've got 0.7 diode drop there, positive on the bottom, and 0.7 there, and not really much that way. Hang on, just make sure. Yeah, this seems to be a normal transistor, not a MOSFET. I'd imagine that's the base. So where's that? Okay, so the base goes through to here, and the other side, wherever that goes, obviously there's no path through from there to there. So if we had battery voltage on here, it wouldn't do anything. So that's interesting. Got some jumpers up there, obviously for setting things. We wouldn't change those, I would think. Well, I'm going to get this out and have a look at the other side. We've got some screws there, a couple up top and a couple down the bottom. Here's the other side, and the mode button in the bottom right corner. Here's the screen, which is stuck on at this point. That's fine. It's not an issue with the screen. And if we have a look down there, all we have is a crystal. There is nothing else down there. So everything's on the back side. So I could easily put this back in the case to work on it. Try and figure out what the go is. I want to blame the EEPROM, to be honest. How about I pop it out, chuck it in the reader, see if we can access it. But yeah, that whole reset thing, let's see where so there's a wire down there off that resistor that goes to the base. So what is actually controlling that? So that runs there, runs up, under the LCD to there. There's two wires there, but it's the one on the... it goes into the blob chip. Anyway, regardless of which one it is, they're all going into the blob chip. Let's make sure of that. Yeah, definitely. Definitely. Well, some function is supposed to pulse that transistor. And that transistor is going to pull that line to ground. To ground? Yes, it is going to pull that line to ground. Which would effectively... Oh, okay, so those wires there on the end of that resistor, they go through to there, which is our mode switch. Okay, which goes up and under, and it's quite a fat trace. Maybe it comes up here through that wire, an equally fat trace. We should check those caps aren't shorted. They could have funny effects on things too. Yeah, because when I pushed the mode button, it activated a reset as well, didn't it? It didn't actually change mode. Such odd behavior. Let's pop it back in, because I think I feel the screen coming detached, is it? Maybe? Yeah, it's sort of come off. Right, let's see if we can access this chip. We have it hooked up to our reader, and I can't auto ID the chip, but I've selected T24C16 because it is a basically that. Let's read it. And it read, and there's not a lot in here, to be honest. So I don't know. Maybe if we save that and erase it and just make it blank, maybe the thing will start from scratch as a blank. I mean, it won't be the firmware. It won't be firmware. There's like far too little stuff there for that. So let's save and save as where are we going to put it? Cool. Okay, we'll just save it there. And we'll just call it stopwatch. And we'll go save. And then I will go erase. Where's my erase button? Device. Erase. Why can't I erase it? That's interesting. What does blank do? Oh, maybe I have to write blanks to it. Or chip blank. What does chip blank do? Does that blank it? Okay, let's do that. Check blank flash failed, not empty. Oh, it's just checking if it's blank. Literally. I'm going to read that again to see if it's all good. Okay. Interesting, I don't have a raise. I don't know. I've never raised a chip before. Maybe it's got some... maybe it's locked so that you can't. If we go clear all buffer, or clear current buffer, there we go. Now it's blank. Now we can program it as a blank. Checksum has mistake. Okay. Maybe I have to remove it from the PCB. Oh, that's weird. It let me program itself what I read back to itself. So it is programmable. Why can't I blank it? Why can't I? How do I erase it? Well, I went clear all buffers and then went and it said continue to blank programming. And it said programming failed. Maybe I got the wrong chip selected. What if I read it now? Nah, it's still got everything in there. Interesting. Even though it went through the motions. What's my options? Force Tech? Maybe it's a Force Tech brand. Okay, let's try that. Probably doesn't make any difference, really. Don't have an erase button still. Clear all. Program. No data loaded. Continue to blank program. Okay. Programming flash with blank and it says fail. Look, failed. Maybe I need to take it off the board. Maybe. What if I just change one bit? What if I make this 2 a 1 and then program it? Will it let me program it with its own? Yeah. Okay. Maybe when I go blank all, let's have a look. Address 7F0. If I go blank all, no, it's still got address 7F0. I thought for a second maybe it made this huge read. So that one was a 2. What if I just made all of these FF? Manually blank it. We'll just do that, shall we, and see what happens. Okay, and then we'll come down to here. And we'll come down to here. All right. Nothing in there. Program. Ah, doesn't like that. So I was doing it right, but doesn't like it. Why? What if these were all zeros? Would it like it then? Meh. Program. Nope. It doesn't like any of that. If I go back to there and there. Nah. Open. Program. Okay. Might take it out of circuit. Take that EEPROM out and see what it does. The most minuscule amount of hot air, so I don't melt everything around it. We will add some lower temp solder to it. See what it does. Yeah, I did just check these little capacitors around the place and they are not shorted. Low air, 350. This is not a very thick PCB. It's not going to take much. All right, I have it back in the programmer clip. Let's see if we can still read it. Reads okay. Let's see if it auto detects. Nah, always says that, but it still reads. And there's still no arrays option. Granted, I'm not that clued up with these, so maybe I'm overlooking something. That's cooled off. I'm going to put the battery in without the EEPROM and see what happens. Error. It just comes up and says ERR. Here we are. Much error. So it needs an EEPROM, that's for sure. Put the chip back on. I'm just going to see if it still has an error, I guess. Nope, no error. And still no functionality. The book suggests shorting those, but for this model number, the diagram shown looks physically different. So shorting those two, which I don't quite know what it's going to do, because as I said, it goes into the collector, not the base. But I'm going to try it, and we'll see what happens. Nothing's happening. Like I thought, nothing's happening. So I wonder if I'm supposed to push the mode button when I do that, because there's the mode button, and that comes up through the wires to that resistor. So maybe you need to short those and push mode. And of course everything goes blank again, but then nothing happens. I have a couple of these, as I said, so I wonder if the EEPROM's contents in another one is the same. It's definitely the same EEPROM. Just give those a clean, and we'll plug in and see what happens. Then I can compare the two. I've got the other one hooked up, and I will go read and read, and it read. And there is a lot more going on in here than the other one. Wow, immediately it's still got the little U there and at the end, but as you can see, this is all mostly full, whereas the other one was mostly not full. I'm just going to go save as, I'll just make a copy of that before I destroy it. I don't think it's going to matter. This contents is totally different, which means it doesn't care what the contents is. It'll write to it the different lap times as it needs, if it can. Save. Okay, here we go. So I'm going to call this stopwatch 2, stopwatch number 2. Yeah. And then we can go to this little program and open file number 1, stopwatch, and file number 2 is going to be stopwatch 2, and then we're going to compare, and it highlights everything in yellow that's different, which is pretty much everything. So yeah, pretty much everything. So honestly, it doesn't care what the contents is, or obviously it doesn't care what the contents is, I should say. So how about I program the contents of that one, this one I just read, and I will program it into our first one that we're looking at that doesn't work. Okay, and I will go program. And it's verified and it's done. So now pop the battery back in. See if it works. No, it doesn't. Oh dear. All the same things. So now I'm starting to think it's actually a blob chip failure. That's not good at all. Wonder what all these different jumpers do. All these solderable jumpers. All these solderable jumpers down the side. I wonder what they all do in the factory config. So we've got 1, 2, and 3. So what happens if we solder number 4? Why not? What's number 4 going to do? So we can always break them. Ah, well, looks like they're going to ground. Because there's a lot of heat being soaked out of my tip there. Looks like they go to ground. Okay, let's just solder number 4 and see if it changes anything on screen. Nope. Ah, but with number 4 now soldered, start stop becomes reset and lap split becomes reset. Well, that's interesting. So that has an effect on, maybe that's button configuration. 1, 2, 3 buttons. 4th button, who knows? Ah, really odd. Let's remove that. Oh, well, let's take all of them off. Let's see what happens if I take off. Well, let's take off 3. And 2. Let's take those off. You see what it does now. I mean, regardless, it still boots up. It must be a button thing. No start stop. Lap still resets. And memory, nothing. And mode still resets as well. Okay. Make sure that is connecting, I suppose. Battery voltage is 2.7, but that shouldn't matter. Do I have voltage on the switch? I have no voltage there. I have no voltage there. Ah, I have 2.7 there. Okay. So when I switch it, it sends voltage out through there. Well, that proves the switch was working when I soldered those terminals, number 4, and that became a reset. It's obviously seeing the signal from it. So if I push the button, I'm getting 2.7 volts through to there. There's 2.7, there's nothing, 1.5. I wonder where it comes to. 4. Okay, got a little boost going on there. The error, of course, is after it was verifying the flash. So let's think about this. Flash address 7E0, buffer value XFF, IC value X55. Okay. So address is 7E00. And buffer value FFFF, which is what I've got here, because I changed it. It's saying that the IC value is X55. which I think is what it was, which means that when it wrote this data back to the chip, it did not write those bits there. Maybe the chip is defective and it can't write to those locations anymore. Let's just read the chip. So here we are, 55, 55. And when I made it FF, it doesn't like it, because when uploaded, it didn't change. When it verified and read it back, it hadn't changed. All of this changed because this is the original file I've loaded back into it. So what if we change address 400? What if we want to make this all F? And we go program, program. No. Address 400. IC value still 55. It didn't change. Why is it not changing? Why is it not changing? Something wrong. I think there's something wrong with these EEPROMs. I need to find another little EEPROM that I can stick on there and see what happens. Just a little FT24C16 or something. Looking for a data sheet. I don't think this one's quite right, because the ST24 version should be, 5 volt. We're only got a 3 volt button cell, so that may not be the one. There's an Atmel, Microchip, Fairchild, a whole bunch of them, except this one, Force Tech. Force Tech. I mean, it did say FT. What if I go back to Force Tech? Unclassified 2-wire serial EEPROM. Oh, here we go. 1.8 volt to 5 volt option. So it's 16K EEPROM, and it's I2C. Okay, so there we go. I need to find a little EEPROM like that and see what happens. Let's not get too carried away. Just to prove that point, let's hook up this other one and see if we can write to those locations, or if they have a different location. I'm just going to read it so we're all the same. So there's the other one with all the extra data, and if I scroll down, I've got 55 at 400 and also at the bottom location there. So let's see, can we edit this location on this EEPROM as well? No. I wonder if it's the same location all the time then, if these chips are failing. I wish that worked, because that would prove that location should be okay. So if I just change 55 to FF, that should fail. And we'll remember that's 55. Okay, so we make that 55. Let's make that location FF. Program. Yeah, 401. No, I can't program that location either. So that was 00. So now I should be able to write that. And I reckon it has 1 million write cycles in the data sheet. Haha. So if I change anything else up here, here's a 55. We'll make that FF. Let's remember that was 55. Program. No. So why? So this is number 2. We've got the file number 2, which we can load, obviously. Browse. Okay, and that's, yep. But what if we load the other one? Stopwatch 1. Will I be able to program the... Well, actually, look. Stopwatch 1 has 55 there as well. So, how does that work? How much of this is allowed to change? How does it even know it's allowed to change? Program. Well, that worked. So that address can change, but that address can't change. Why not? Can I change that address? Yes. Can I change the last one down here? Yes. Why would it just be... That was 0, 0. Why would it just be the 55s? Ooh, I can't do that either. Why would it be the whole line? Is it the whole line? Let's change the last one. So the whole line is out of action. I'm going to load that again. Load, stopwatch 2. That's what was in there. Let's put the whole thing back in there. But yeah, it starts with 55 at each of those sections. What's special about those sections? 0, 400, 70, 0. What if I change this one? That works. It's happy with those lines. Just not. Let's try all of those. No! Ooh! 3E0. 3E0. That one doesn't like to change. That's interesting. I wonder if when you power up, when you put a new battery in, if it tries to write F's to the whole thing and erase it, and it can't. And so it just, I mean, you'd think it would come up with an error like when you turn it on without an EEPROM, but maybe not. Maybe it just starts up and doesn't function. It's bizarre. So without another chip that's like known good, because they both can't write to the 55 locations. Holy! I think I did it again. I have the EEPROMs that I ordered for I may have made a mistake. It's just holy moly. It's one lot. A quantity of one is 10 pieces. I think I might have ordered 10 lots of 10. I've got 100 EPROMs. If anyone needs one, let me know. I'll happily sell them on. But anyway, joking aside, yep, I will never use all of those. However, at least if we make a mistake, I've got spares. There were so many that they had to cut 2 extra off the roll as well to make up the difference. So go figure. But now we get to play, and let's see if we're on the right track with this. I'm not entirely sure if they even need to be programmed. They could be completely blank and it might work, because the program data between the two stopwatches was different anyway. So I'm wondering if the stopwatch itself just sets up what it needs. But I think I'll program one and I'll leave one blank, and that way we can just swap it over and see what happens. I should have used this little chip adapter last time instead of fiddling around with the horrible little clamp trying to get it to hold on, but here we go. I don't use this so often, I forgot I even had that. Alright, let's load our file. Where do we put that? Stopwatch original. Open. Okie dokie. Our chip is an FT24C16A, which should be the same as what I ordered. Let me just double check that. And it is a 24C16N. Should be good to go, surely. So if we, I wonder if we just read the EEPROM as it sits. Let's do that first. Let's do that. Just see if it's in the adapter. Should come back as a blank. And it says bad pins, so I'll just jiggle the adapter. I can do that sometimes. Okay. There we go. And as you can see, FF everywhere, not a drop to... No, wait, that's not right. Let's reload our file and program that, and it should program. Success. Cool beans, which means it was able to write this funny little address down here at 55, or address 400, address 400 onwards, and down the very bottom, that one there. So that changed from F to that. Cool. And I've also got a blank one there, so let's first just drop the blank one into the stopwatch, and on a nice low airspeed so we don't melt everything, and I'll just plop the other one straight on. We will pop in the battery and see what we have. We have the same thing as we did before, so let's try our luck and push the start stop button. It didn't feel right. Try that again. Nothing. Boo. What about the other button? That's the lap split reset button. Does a reset. And a mode. Mode also does a reset. Oh no, it may not have been the issue. Still, let's pop in a programmed flashed version. See if that makes any difference at all. The program chip is in, inserting battery. And that's what we have. I didn't quite realize how much glare there was before, but anyway, pushing start stop button now. Nope. Nope. Mode button still causes a reset, as does the other button. Well, that's not good. So I thought I'd put in the blank one that we put in to start with. And what's interesting is it did write to it. So it's put in at the start location 55000000, and then a couple of other bits. And then down at 400, it's programmed that in as well. And down at the end, well, almost the end, not quite the end, it's put that. And I think our original file had that at the very end. So this has gone up to 7F0. Let me load in the previous one. That also goes to 7F0. So that's good. That means it's addressing everything correctly and that the chip I ordered isn't wrong. I thought I was so close. I'm kind of scratched for ideas. Yeah, that's interesting. Well, it really looks like the Ultrak 495 stopwatch has a built-in expiry period, eh? I mean, the EEPROM I'm sure was bad. Both of them that we checked, it could not rewrite new data to those two locations, those two memory addresses. So that was an issue in itself. And now that that's resolved, the thing still doesn't function, even though it has written to the blank chip. So there is some functionality there. If anyone has seen this before, maybe you've got an idea as to what it could be, let me know down in the comments. It's a bit of a shame though, they're not too cheap, they're not the most expensive out there I don't think, but they do cost a bit. So, and it's roughly the exact same lifespan as well. They all last so many years, and then yeah, they all fail with the same result. So anyway, let me know what you think, and we'll catch you all in the next video.